Hi, sir. Good morning.
Hello, Vikas. Good morning. How are you?
Yes, sir. Good, sir.
Okay, Vikas, let me start the session. Hmm. So, we have discussed yesterday the transmitter part. Today, we are going to explore the receiver part. This particular USART communication has both transmitter as well as receiver, right? Both of them are serial communication, right? So the receiver block diagram is shown in figure 10.4. The data is received on the RC7. RC7 is the port to C 7th pin in the microcontroller. So that is called as RX or DT pin and drives the data recovery block, right? The data recovery block is actually a high speed shifter operating at X 16 times baud rate, whereas the main receive serial shifter operates at the bitrate or at FOSC. That means the frequency of the oscillator. Right now, so meaning what they are trying to say is it's just like a capturing unit which simply capture the incoming bits with a high speed, right? So that they are able to reconstruct the received bits. Once asynchronous mode is selected, reception is enabled by setting the CREN, meaning once you have selected asynchronous mode, reception is enabled, meaning the CREN bit should be set to 1. If it is not set to 1, your receive is not enabled, right? So we have to set that. It is part of RCSTA bit, RCSTA register, right? Heart of the receiver is receive serial shift register. So there is an RSR, right? This register is the heart of the receiver. After sampling the stop bit, the received data in the RSR is transferred to RCREG. That is a complete register that you can read, but you cannot read RSR. If the transfer is complete, the flag bit RCIF, that means receive interrupt flag, which is part of PIR1 fifth bit, is set. So when there is a successful reception, they create an interrupt RCIF. The actual interrupts can be enabled or disabled by setting and clearing enabling bit. Actual interrupts can be enabled or disabled by setting or clearing enable bit. So there is a interrupt enable control bits as well. It is called as RCIE, receive control the receiver interrupt enable bit, which is part of PIE1 peripheral interrupt enable 1 register fifth bit. Flag bit RCIF is a read-only bit which is cleared by the hardware. So we no need to clear the RCIF, receive interrupt flag. It is cleared when the RCREG register has been read and is empty. Moment you read the RCREG, automatically RCIF flag will be cleared. RCREG is a double buffered register. It is a double buffered register, meaning first in first out. Whatever which is coming first, which is that we can read first. So it is such a register. It is possible for 2 bytes of data to be received and transferred to RCREG FIFO, and the third byte to the third and a third byte to begin shifting to RSR register, meaning that you can even do a 2 byte exchange. That is what they are trying to say. On the deduction of stop bit of the third byte, if RCREG register is still full, the overrun error bit OERRR will be set. The word in RSR will be lost. RCREG register can be read twice to retrieve 2 bytes in the FIFO. overrun bit OERRR has to be cleared in shift software. This is done by resetting the receive logic. CRN is cleared and then set. If bit OERRR is set, transfer from the RSR register to the RC/REG register are inhibited and no further data will be received. It is therefore essential to clear error bit if it is set. Framing error bits FERRR is set if stop bit is detected as a clear bit. FERR and the ninth receive bits are buffered the same way as the receive data. Reading RC/REG will load the bits to RX9D and FERR with the new values. Therefore, it is essential for the user to read the RC/STA register before reading the RC/REG register in order to not to lose the old FERR and RX9D information. This is the diagram for receiver. So we have a from F oscillator we are getting serial port baud rate generator. From there it is plus 64 times or plus 16 times, whatever the SPBRG, right, that is multiplied by 16 or 64 is used as a data recovery register, right? It simply samples the incoming serial bits and it look for stop bits. Moment it find the stop bits, it's transfer. Actually, it is simply shifting the values to this RSR register from start to stop. Moment stop bit is enabled, stop bit is received, it transfer the entire data to RC/REG. RC/REG is a receive register. Moment we get some data in that, we get RCIF receive interrupt flag that is set right now. So that is how it works. So if you look at this block diagram, initially you cannot understand anything. Moment we do some practical things, you will get some idea, right? We are going to write a program for that. Here is the logic. See, we are receiving startup bit, right? In that time, they are simply shifting to RSR. The moment they get a stop bit, right? Moment they get the stop bit, that is entire content is shifted to RC/REG. At that moment, we also get an interrupt. Right? If there is an error, they are setting those errors. When setting up an asynchronous reception, follow these steps. Initialize SPBRG register for the appropriate baud rate. If the high-speed baud rate is desired, set BRGH USART baud rate generator BRG. Enable asynchronous serial port by clearing the sync and setting the SPN. If the interrupts are desired, then set enable bit RCIE. If 9-bit reception is desired, then set RX9. Enable the reception by setting the CREN. Flag bit RCIF will be set when the reception is complete and an interrupt will be generated if enable bit RCIE is set. Read the RCSTA to get the 9th bit if enabled and determine if any error occurred during the reception. Read the 8th bit received by the data by reading the RC/REG. If error occurred, clear the error by clearing enable bit CREN. Right? If using interrupts, ensure that GIE and PIE of the incont registers are set. We have to follow all these steps in order to get a successful reception. Registers associated with asynchronous reception. These are the different registers that you will work with. Intcon, PAR1, RCSTA, RCREG, PIE1, TXSTA, SPBRG. These are the different registers that we are going to work with. This is like 9-bit mode. I don't think we are going to work with that. We no need to bother about it. Okay, up to that, you said asynchronous mode is over.